Наушники подключить.
Да. Так.
Вопросы потом всего.
Да, мне надо будет потом. Okay. Uh, we're starting our new event for today. Before starting the general presentation, I would like to know if you can hear me or see me well. Please send the plus sign into the chat box so I could be sure that you see me and hear me well. And if everything is fine, we will start our demo. My operator says that everything is fine and everybody can hear me and see me well, so we will start the presentation. My name is Dmitry. I'm responsible for technical consulting at TECHNO-AC. We are a Russian company. We are manufacturers of cable and pipe location solutions. We are manufacturer of contact thermometers and electric test vans. So generally, we work with the equipment. We produce the equipment which allows you to locate and inspect the underground utilities. Everything which is buried below ground surface can be located and can be tested with our equipment. Our company was established in 1992 by famous Russian inventor Sergei. And by today, we're having a company which has more than 100 people working for us, and we're developing and manufacturing the equipment by ourselves. And generally, today we're going to talk especially about one model of equipment, which are complete representative of mid-range equipment from TECHNO-AC. And this is going to be one of our most demanded models of cable and pipe locators, which is called AG-438.15N. Yeah, the name of this device is kind of complicated, but you can call it just Success 438 because there are no other equipments with the same name, so it's fine. We will understand you. And again, my name is Dmitry. You can call me Dima. And before moving to the actual demonstration of the equipment, I would like to say one more thing. If you have any technical questions aside from this particular demonstration or aside of this particular model of equipment, I mean, if you have questions about any model of our equipment, you can contact us through WhatsApp, through Skype, email, or through our website. We are almost 24/7 online to support you and to provide all the information about our devices. Okay, so generally, uh, I guess we have finished the introduction part, and we will move to the theoretical and to the practical part of our today's event. First of all, let me start with the explanation of how our devices locate the cables and pipes. Let us start with the first statement. We don't locate the cables and pipes, we locate the signal which is coming from these underground utilities. Today's equipment, 438.15N, a locator, is locating metal cables and pipes. What does it mean? It means that the utility which you're locating should be able to conduct electric current or electromagnetic signal, which is the same. And our equipment detects this signal from live power cables, from metal pipes, or this equipment allows to create this signal in dead underground utilities and locate them with the help of this signal. Every underground utility location equipment utilizes the same principle, the evaluation of electromagnetic signal. So what does it mean? It means that in order to locate the metal cable or metal pipe, you have to locate the spot with maximum signal. Electromagnetic signal has its different levels, and when you're approaching to the spot of maximum electromagnetic signal, it means that you have located the cable or the pipe. We have some methods of location which help to evaluate the depth and current which is flowing through the given utility. But generally today, we will be only detecting the cables and the pipes. So let us move on to the set which we're going to represent to you today. The core of every set of cable and pipe location equipment is the receiver. In this particular case, we're using multifunctional location receiver AP27. This device allows not only to locate metal pipes and cables, it also allows you to locate water leakages, to locate plastic pipes, and also locate uh, faults of electric cable, high voltage cable, when it is used with high voltage uh, surge wave transmitter. Today, we will be using it as metal cable and pipe locator. And first, I am offering to locate the energized 50 hertz cable. You know that power cables, most power cables, are working on 50 hertz frequency. In some countries, this frequency is 60 hertz. It happens. And this device also can support this frequency. So it doesn't matter from which country you are, you can just switch the device to the power frequency of your location, your country, and detect live power cable. So how do we do that? We take the receiver, we turn it on, you see the firmware indication and the basic menu of the device. You see that this sign says that we have nothing connected to the receiver. And now I am taking the electromagnetic sensor, which we will be using for the location, and I will be connecting it to the receiver, and let us see what will happen. We're taking the connector, aligning two red dots here, these two dots, and we're connecting the sensor. See, the device automatically switches to cable location mode. There we go, we're almost ready to locate the cable. I'm pressing the measurement button here to start the measurement, and we have to switch the frequency of the device. I will tell you briefly what do we see on the screen. We see amplification or gain level. We see selected frequency. Now it is 1 kilohertz, but we will switch it. Here is the scale of the graphical indication, and here is the volume of the sound notification in your headphones. I will show you how does it work a bit later. And here we're having the scale, which is now 0, which will be representing the signal level for us. The maximum signal level will tell us where is the cable. Okay, let me switch the frequency now. By pressing F button here, we can switch the frequency with arrow keys. See, I'm switching the device to 50 hertz with arrow keys and confirm my selection by pressing F button again. So now device acquires all the signal on 50 hertz frequency. After that, I will connect my headphones, which are supplied with the set. and I will be able to hear the audio indication of everything that I locate. Let me put on my headphones around my neck so you and me can hear what's happening in the headphones. Let's go. We will go to our power cable, which is not far from our building, and I will be demonstrating how to locate the cable. And before doing that, I would like to show you our building and something that we have a work in progress now. Okay, let me uh, be like this, like this. This is our test vans, which we are currently producing. You see, we have several of them. Now it's 5 cars. So these are high voltage test vans, which we are currently producing for Russian and international market. You can see a TECHNO-AC logo on them. And these are basically Russian cars, heavy duty cars with international, German, Russian, and other international high voltage testing equipment. Now they're being assembled, and this is kind of a new business for us. We're doing it only for 5 years now, and mostly do it in Russia. But I hope that one day we will be able to supply these cars worldwide, maybe. Okay, let's move back to our uh, power cable. This is the back of our building, and below this ground surface, there is a power cable which supplies our building with electricity. I'm 100% sure that this cable is having electric current running through it, and we will be able to detect it with our sensor and receiver. Let's do this. So what do we do? We take the sensor and receiver in one hand and sensor in another hand, like this, and we're swinging the sensor left and right in order to check for electromagnetic signal. Let me show you how I do it personally. I take the sensor like this, and I'm starting to walk from one side to another and evaluate the signal which I can locate, like this. I go all the way back and forth, just evaluating the signal. Let us do this observing the screen of the receiver, like this. So now we're having 10 something signal. You see that it increases while I'm moving the sensor. It is 15, 12, 11, 10, 9, and it's decreasing. So I'm moving the sensor back, and it's increasing again. 13, 12, 13. I guess our power cable is here because this is the spot with maximum signal. And in order to continue the location of the cable, we can mark the spot with maximum signal, and we can carry on swinging the sensor left and right and checking the signal. And the maximum signal will tell us where the cable is going. When you are moving the sensor away, the signal decreases. When you are checking, uh, the signal increases again. The main thing here is that uh, you don't have to have 100 full scale for that. You just have to have the maximum signal out of possible in a given condition. So there is no strict rule that you have to have 100%. Just hold on a second. 100% signal. Okay, let's do the following. I hope that you can hear now the signal which I'm currently trying to show you. Hold on a second. Okay, so what I'm trying to show you now is that also the device has an audio indication, and when you're approaching with the sensor to the cable, the pitch of the sound is changing, it becomes higher. So when your sensor is away from the cable, there is one lower pitch of the signal, and when you're approaching to the cable or to the pipe, it doesn't matter, but in this particular case it's a power cable, the signal will increase. The pitch of the signal, sorry. Also, there is so-called natural sound, which is giving you the buzz when you are locating the cable. I hope you can hear it because this sound is very annoying. I hope you really can hear it. So let's get back to our table, and we will be moving to the cable or to the pipe, which is having no current at all. And before doing that, I want you to choose what are we going to locate now, the cable or the pipe? Because some of our visitors, they request the location of pipes, and some of them request the location of cables, and we will do both. But I would like you to choose cable or pipe. You can type in the chat box what do you want to be located first. If it's going to be a pipe, that's fine. If it's going to be a cable, that's also fine.
Right.
Pipe? Okay. The first request was the pipe. And each set of TECHNO-AC equipment has this little thing supplied. It is called magnetic contact, which we're using for the pipe location. And for test purposes, we're also having a pipe which is not buried, but it's still above the ground surface. And we use it for the demonstration and for the leak detection and for many other applications. But we will be using the magnetic contact and the pipe to locate the pipe to demonstrate to you how are we going to do that. So first, you have to apply a magnetic contact to a metal part of the pipe. Easy as that, like this. Now you have installed the magnetic contact. Another thing that we're going to do is we're going to connect the lead, which is coming from the transmitter, to the pipe. Let me just take the equipment with me. Oh, I guess we need some more more lead. Let me try. Let me try. Where is the? Oh, there it is. Yeah, that should be enough. We'll just put it like this. Okay. Yeah, that is fine. That should be enough. Yeah. Okay. You have to connect the transmitter cable to the pipe on one side and ground your connection on the other side. Let me show you. This is the grounding stake, which is also supplied with the set. You stick it to the ground as deep as possible and put on the crocodile clamp on it. Easy as that. And now we will be creating an electromagnetic signal in the pipe with the AG-105 transmitter, which is also supplied with the set. This transmitter has multiple features. First of all, it's very lightweight. It weighs only 2 kilograms. Also, it has a built-in antenna, which allows to install it above the metal pipe and induce the signal without connection to it, for example. And it has multiple functions, I mean the frequencies. The first one is zero point 0.5, it is 512 kilohertz. Another one is 1.0, it is 1 kilohertz. Also, it has 8.28 kilohertz and 33 kilohertz. Generally, we start, for those of you who are familiar with our webinars, we start with the lowest possible frequency. But today, the ground is very cold because it's already winter in Russia. And the signal is traveling very poorly through this cold ground. And we will be using higher frequency, 1 kilohertz, in order to locate the pipe. Let's do this. Now we started the transmission of the signal, and the transmitter is gaining its power in order to create some signal in the pipe to which we have connected previously. I will take the receiver meanwhile. Yeah, like this. Transmitter is giving its full power to the device, and we're moving again to the receiver, and I will be showing to you how to use this with. So now we have a transmitter connected to a pipe and creating an literally electric or electromagnetic signal in the pipe, which we have to locate somehow. What do? We have to enable the receiver on the same frequency as the transmitter. Again, we turn on the receiver. It's already working in a location, cable and pipe location mode. We press measurement button here, and we press frequency button, and we're switching the frequency to 1 kilohertz in order to select the frequency of the transmitter. Now we are ready to go. I will add some amplification. Oh, yes, the signal is very poor because the pipe. Ah, there you go. Yeah, please let me show you. Uh, so now we're having we're moving the sensor away from the pipe, and I will add some amplification so we could check the signal. So when I'm having the sensor away from the pipe, the signal is very low, but when I'm putting it closer to the pipe, the signal increases, you see? So the procedure is the same. You're swinging the sensor and you locate the maximum signal. You see that the signal is very low because the pipe is cold and the there is a bad connection to the pipe because it's covered with the paint, and you can see the pipe can be easily traced. And all you have to do is swing the receiver and go all the way along the pipe. Of course, these conditions are not the best because it's winter and the signal is traveling poor because we have the limitation of our connection cable. But generally, the procedure will be the same as with the power cable we've located previously. You just go and swing the sensor and check if there's any signal. And the point with maximum signal will tell you where is the pipe. So generally, that's how it's done. Let us switch to power cable, which is carrying no current at all. That should be also interesting. Let's move back to our table. We will be using the same settings of the receiver, but and the same settings of the transmitter. We just change the connection of the crocodile clamp. We just switch it to a cable, which we're having here. Just hold on a second. Just hold on a second. Here we have a cable box. Uh, every lead of this cable is split, and we're connecting to one of the leads in order to demonstrate how does this thing work. The cable goes here, it goes all the way approximately 1 meter left from the pipe. So there's the pipe we've been locating now, and cable is going somewhere here. We will be trying to locate it also with the same equipment. To do that, we will switch the transmitter on the same frequency, 1 kilohertz. I already made all the settings, and I just press the start button in order to create a signal and to see if we're able to locate the cable, which is laying nearby the pipe we've been locating previously. Okay, we're also having full signal, and I'm switching back to the receiver. We already input all the settings, same settings as we had for the pipe. I'll just try to turn on the device and show you how we're going to do that. Just give me some time. I will turn off the indication because, yeah, I will just turn down the volume a little bit, but I'll still keep it. Maybe you can hear this funny melody, but it's not a melody, it's the signal level. So the procedure is the same. You see that I'm standing away from the pipe we've been locating previously. And now I'm moving the cable across, and I hope you can hear in my headphone side how the signal is changing. And the procedure is the following. Экран покажи, пожалуйста. See, now I will be approaching the sensor to the cable. The signal gets almost high, almost 100%, like this. And this is the way we're going to trace the cable. We'll be swinging the sensor left and right, checking the signal and observing the cable. If the cable is going to turn left or right, we will see because the signal will change. And we will be able to go all the way uh, alongside the cable. And if you remember, when we started our event, I told you that this is a detection device and it can't measure the depth of the cable. I lied to you because I know how to locate the depth of the cable. And today I'm going to tell you how it's done. So let us do the following thing. We will take one spot of the cable. Let me locate it. Иди сюда, пожалуйста. We will locate the spot with maximum signal now. Let it be. Yeah, it should be 66, 60. Yeah, this is the spot. I'll take this stone. I will mark the place where is the cable. This is where the cable going. Let's do it this way. It goes that way. And now I will be switching the position of the sensor 45 degrees like this. And now I will be able to measure the depth of the cable. Let me show you. So I'm placing the sensor head right above the stone with which I marked the cable. And now I will be going back. I will be going back away from the cable and I will be observing the signal level. The thing is that maximum signal point will tell me what is the depth of the cable. And the depth of the cable will be equal to the distance between sensor head and the stone. That's the feature of electromagnetic location. So let me show you the screen from the beginning. I'm placing the sensor head on the stone, which is marking cable, and there is almost no signal. And now I'm moving the head of the sensor back from the stone. See, the signal is increasing. I'm moving it away from the cable. 33, 32, I guess this is the, yeah, I guess this is the distance. And we're having something like 50 centimeters here. Yeah, my operator shows it with his own legs. So it's like 50 centimeters. And this is the true depth of this cable. So this is how you can measure the depth with the device which is not having any digital depth measurement feature. That's quite handy in some cases. It won't give you the precise, with 1 centimeter fold, precise depth. No, it's not like that. But it will give you approximate plus minus 5 to 10 centimeters evaluation. So you can assume that the depth of the cable is something like that. It's not the precision method, but it helps a lot in many cases. Okay, so I guess this is almost it for our today's event. I'm just I want to add something to our presentation. Also, if you remember in the beginning of our event, I told you that this core of our set, the receiver, is multifunctional. And what I'm trying to say is that this device can also locate the leakages, the water leakages from the pipes. And to do that, you just need the acoustic sensor, which is also called the ground microphone. This is kind of small but heavy device. It also detected automatically like this, and the device automatically locates starts to work in the leak detection mode. Today, unfortunately, we will not be showing to you how to locate the leakages because that's not the topic of our today's event, but generally there is such feature, and if you're interested, we can make this, we can demonstrate. Still, the weather allows us to do that. The winter is not that harsh in Russia, but that's fine. Okay, so today we gave you the information about the general process process of cable and pipe location, how the electromagnetic location works. We've located 50 hertz power cable. We located metal pipe. We also located that cable by creating the signal in it with the AG-105 transmitter. And now there is the point of our event when you can ask your questions and I will be answering them. I will take another phone and I will be reading your questions and answering them. Ты мне свой телефон дать можешь?
Не могу зайти, что-то он не выпускает.
Ага.
Ну, можешь перевернуть камеру.
Okay, I will be switching the phone to my face to my face camera, and I will be reading your questions for now. Okay, let me do this. Oh, everyone selected the pipe. Yeah, okay. Is the PA pipe or a metal pipe? Our pipe was made of metal. The PVC pipe and plastic pipes can be located with the device which I am having with me today on occasionally. Just give me a second. It's like this. Let me switch the camera. For plastic pipes, we're having this device which is called impact device or striker. You install this device on the pipe and it strikes the pipe and creates the signal, which you have to locate with the acoustic sensor. The thing is, I can't show it to you right now because we're not having a transmitter which supports this feature. Generally, we have a dedicated event for plastic pipe location, and you will be able to see it in some time. But for now, there is just this device. I'm occasionally having it with me in my bag with demo equipment. Okay, Actually, we're looking for a solution for non-metallic cable and pipe, PE pipe locator and fault locator. Okay, for non-metallic cable, unfortunately, I can't propose anything to you. But for plastic pipe, there is a device which I showed to you just now, and also we're having acoustic fault locators for the cables. But again, they should be made of metal. If the cable is not having any metal, suppose it's an OFC optic fiber cable. There is no way to detect its faults with our equipment because you need an optic fiber TDR for that, time domain reflectometer. For metal, for power cables, for electric cables, for network cables, we're having our own TDRs, and we're having electromagnetic fault locators, the insulation fault testers, the accessories for the selection of the cable from a bunch, and many, many others. And we will have a dedicated webinar, dedicated event for the accessories. Please invite me when you do electrical cable fault finding and water leaks. Okay, let me do the following. Each time we are having a webinar, we are sending the records of previous webinars to all our visitors, to you, to be precise. And after this particular event, I will be also sending the list of our previous videos, and we will be using there will be a fault location webinar and water leak detection video and webinar also, and there will be the same demonstration done by me, and I will also invite you to our upcoming event for sure, so you could see everything with your own eyes in real time. Yeah, of course we will do that. If there are any questions, this is the best time to ask them. I now this demo is not for leak detection, but asking this question intentionally. We're looking for acoustic leak detection, which can detect leaks up to 8 meters depth. Could you provide some recommendations, please? Generally, for your recommendations, we have nothing in our range, but generally you can use a correlator water leak detector. We're providing acoustic leak detection only for 3 meters depth. If the depth is more than 3 meters, then it's hard for our equipment to locate the depth. But correlators, they can do that, but you have to have access to the pipe or to the manhole where the pipe is coming from. Can we detect vertical wall pipe? Yes, if there is a spot where the pipe is visible and you can connect the transmitter to it and create the electromagnetic signal, yes, you can detect it, or you can apply the transmitter on a low signal level, and yes, you will be able to induce the signal on the pipe and locate it afterwards. Yeah, it can be done with some minor inconveniences, but yeah, it can be done. Yeah. Any other questions? We're still waiting for your questions. Meanwhile, let me show you our building and the whole thing once again. This is our production site. This is where we located the energized power cable. Is there any clearance required between the detector and transmitter? What do you mean by clearance? You mean the distance. Okay, I will explain. See, when you connect the transmitter to the cable, you need to give some space in order to start the proper location. And the clearance, how you say, is should be minimum 3 meters, because the signal will be overloading the equipment, if you're locating right near the connection spot or right near the transmitter. Yeah, the signal will be overloaded. Leakage can only be detected using acoustics, right? Yes, water leakage especially. Current leakage can be detected electromagnetically and with TDR, but generally for water leakage detection, yes, it detected only acoustically. You place the sensor, the microphone, above the pipe, and first you listen to the noise of running water, the water which is running through a pipe. You remember, you store this the frequency of the running water in the device's memory, and then you are trying to locate the maximum level of the signal, and the maximum level of the signal will give you the spot where the leakage is laying. So this is how it works. Yes. Okay. Any example? Locating pipe within the washroom wall around 2 by 2 meters square. Again, the procedure will be the following. You connect the transmitter to a pipe, you decrease the signal to the lowest possible level on the transmitter, and you're locating the pipe. Or if the pipe is not visible, you put the transmitter to the wall, and you create the signal on the pipe also on the lowest possible level, because if you start the transmitter on maximum level, it will induce signal on every metal object around it, and everything will be visible by the receiver. So that is why you will have to make the lowest possible signal, and that's how you will be able to locate the pipe. Okay, I thank you everyone for joining us today. I hope you got some useful information, and I hope that you stayed interested in TECHNO-AC equipment, and that you will visit our next events. The next event we are planning to have in 2 weeks. I see that there are some more questions. Is it possible to detect buried PE pipes from the surface? Yes, it is possible. It can be done with GPR, ground penetrating radar. Unfortunately, we do not supply this equipment, uh, but you can purchase it from any other vendor. That's no big deal. Uh, I'm pretty much sure that the price of this equipment will surprise you a little, very much, because this equipment is very expensive. And the training is much more complicated than training for our equipment, for example. But yeah, it can be done. How to adjust the lowest signal? That's very interesting information. Let me show you. So when you have enabled your transmitter, when you suppose started it on full power, I will just pause it. Just give me a second. Like this. You can increase or decrease the signal level by arrow keys on the transmitter. So you can select the lowest possible signal by doing that with arrow keys. I guess 3 volts will be enough for the pipe location in the washroom. And you can increase it. You can see 3.3, 3.5, 3.8, and you can decrease it. So you have to set the minimum signal for this operation. That's how it's done. Is this Techno device is waterproof? Those parts of the device which are contacting with water, they are waterproof. But generally, for receiver, it is IP54 protected, and also the sensor is IP54 protected. The acoustic sensor for water leak detection is IP65 protected, and the transmitter is also IP65 protected, but only when the lead is closed. with open lead, it's only for 54 also. Okay, is there any more questions? Can it be used in raining? Yes, it can be used during the rain. Not the tropical rain or monsoon rain, but generally, yeah. If the rain is not that heavy, it can be used. Let me switch the the headphone. Just hold on a second. Yeah. Okay. I see that there are no more questions. I thank you again for joining us today. I will send the record of this webinar to you afterwards, after this event ends. Thank you very much. Pleasure answering your questions. I'm glad that you're interested in our equipment. Thank you very much. Bye bye. Have a nice day. Stay safe. Bye bye.